Hello, I'm Bo from Sweden. Welcome to my channel about the WICS project. Today I'm happy to announce that the PCA9685 board is ready and the WICS code is in a release candidate 1 state. We won't waste any time, so let's start. The existing 1.0 version of the PCA95 PCB is mounted in 6 easy steps, starting with the lowest component and finish with a 22 microfarad capacitor. While I was mounting the components, I found room for improvements. Here is the updated version of the PCA9685 PCB. It's only 40 by 25 mm, 2-layer with the following improvements. 2 connectors for the PCA9685 modules for either server or LED. Bigger 5V input, so you can have both a 5V cable in and out to the PCA9685 module. A protecting diode when both 5V and USB are connected. Adjusted mounting holes for the ceramic capacitors. Improved describing text that make the mounting safer. When connecting servers, remove the 5V jumper and connect the 5V cable to the screw connector. When connecting LEDs, use the 5V jumper to supply 5V to the LEDs. Each port on the PCA9685 can handle maximum of 25 mA and in total maximum of 400 mA. That is because we are using something called drain mode. If we were using normal mode, the maximum load is only 10 mA per port. To simplify LED connections, I can highly recommend WICS LED adapter. Here we can see how it looks. I just put in some test LEDs. And here you have the resistor bridge, the 220 to 1K ohm resistors I recommend. And I just plug in, well, of course you will have cables, not LEDs in real life. But you'll see it just plugged in like this. And then I put this LED adapter directly to the module. And that should be connected to the red and the yellow pins, right? You see here. Oh, I got it wrong, one step wrong. I have to move it one step. There we go. And boom. And then you just connect the module to the WICS board. And like this. And it's done. Easy. To install the WICS software, disconnect any 5V power and restart the microcontroller with a USB cable. If you upgrade the software, you can use USB Connect to download existing configuration files. If you have any problem with hanging installation or error message, put the microcontroller in flash mode. For ESP32C6, press and hold the right boot button while powering up with a USB cable. Then release the button. For ESP32S3, the boot button is on the left side. Open your Edge or Chrome browser and go to https://realwireless.github.io/WICS install. Now you can see how it looks. We have radio buttons. Today you can only select gateway and the PCA board. Click connect and it's connecting. And then you say install. There's the wrong version number. It's not 102, it's 110. I will correct that. Then it's starting erasing everything on the microcontroller. And it will install. And it said it will take 2 minutes, but I will pause. We are not waiting 2 minutes. Now it's wrapping up, and closing up the installation. You see her now. Should be any second. Yeah, here is the installation complete. So that's all. It's simple and easy.
Here you see the parameters used to set up LEDs. Using a configuration for our demo is 2 red LED on port 6 and 7, DCC, address 107 for a railroad crossing. Both ports have the same DCC address. 1 LED strip on port 9, DCC address 109. 1 white LED on port 15, DCC address 115. We have also defined 1 servo on PCA9685 Model 2 with address 41. Here you can see the parameters used to set up servos. The configuration used for the demo is servo on point 0, DCC address 120, when 0 moves 50 degrees, when 1 moves 150 degrees at a speed of 500 milliseconds. Today we are working with the latest WICS version 1.1.0 and nowRail version 2.1.0 that's released public any day. To control the PCA9685 boards, we are using the gateway and the remote control D button. This demonstrates that WICS and nowRail can be used standalone without any external connections. One click will send 120.1 to the servo, 2 clicks will send 120.0 to the servo, 6 clicks will send 107.1 that turns on the railroad crossing, 7 clicks will turn it off, 8 clicks will send 115.1 that turns on the arc welder. We didn't assign any button to turn it off. Every minute at the second 0, the time ACC will send out 109.1 that turns on the LED strip. And every minute at the second 30, the time ACC will send out 109.0 that turns off the LED strip.
Here we will show you how the system works. To the left is the WICS gateway board with a system monitor and a 4-button remote control. The gateway is sending out DCC command, DCC addresses, either because the button is pressed or by a time schedule. If we connect the DCC command station to the gateway, DCC commands from the system will also be broadcast out. To the right, we have the WICS PCA9685 board. We're using 2 boards, one connected with LED at address 40 and one with servers at address 41. Let's look at the system monitor. If I click once on the D button, it will only activating the clicks. If I don't click, it turns off again. So now I will click 7 times to get 6 clicks. And that will turn on the railroad crossing you can see on the right. Also, when it's 30, it will be sending 1090 turn off, but it wasn't on. So now I click 8 clicks, registering 7 to turn it off. If I click 9 clicks in total, I will have address 8, and that will turn on the arc light. Yeah, arc welder. I don't have any off command for that at the moment. But you can see that now when it's getting to 0, it turns on the LED strip. That is the functions. It can be used with or without the DCC system. Let's continue the demo with servers. One click send the address 120 with logical 1, move the server to 150 degrees. You can see that on the right now. If I do 2 clicks, it will move the server 50 degrees. Yeah. So 1 click, 150 degrees, 2 click, 50 degrees. Yeah, you see it working well. One thing to remember is to be careful not to schedule addresses that doesn't exist or that's not connected. nowRail tries to send a command several times when no acceptance is returned, and that would cause a lot of unnecessary traffic. WICS and nowRail software, C++ code is open source, free to download, use and develop. Just go to https://github.com/willwireless/WICS. And it will look like this. You have some folders containing the code, and also there is instructions down here, and you can see create a folder that have to be named nowRail in your Arduino sketch folder. Download the files, and then you replace with the actual board the files that is in that folder. So the nowRail is containing the original nowRail code without WICS. Then you just select the board, in this example here, PCA9685, and you replace all the files that you have copied with these files. And you can see there is no libraries, it's only the ESP32. Here you see the code that is used. There is also the sample file of the configuration file PCA9685.txt. In the doc folder, I will produce, now it's only 2 small documentation, but that could also contain more heavy documentations in PDF files. Yeah, that's all. That's simple to download, use and see the code.
Thank you for watching this video. Hope you enjoyed it. We look forward to sharing our next video with you. Until next time, take care and happy railroading.